So, example 7, chapter 3.2. Find the least number of terms required for the sum of to exceed 2000. So, if we take that first thing and we want to form an inequality. So let's just pick out the key things. The least number of terms to exceed 2000. So we want Sn to be greater than 2000. Right? State inequality. And then substitute into the inequality. Well, what can we substitute in? Let's check here. So our common differences are plus 5, plus 5, plus 5. So we have got a common difference, so that's equal to D. We've got a first term, so that's A. So hopefully we've remembered that Sn is equal to n over 2 times 2a plus n minus 1 lots of the common difference. So here we don't know what n is. So we've got n over 2. We do know that a is 4. So it's 2 lots of 4 plus n minus 1 lots of the difference, which is 5. So we've got n over 2 times 8 plus 5n minus 5. Tidy it up, n over 2. Collect the like terms. So we've got 8 take away 5 to leave 3 plus 5n. And now we've simplified that. We can substitute into the inequality. So we get n over 2 times 3 plus 5n. We could have substituted in earlier, it wouldn't have mattered, is greater than 2000. Equation with the fraction, and now we've just got to solve it. Multiply 3 by the denominator, so we get n lots of 3 plus 5n is greater than 4000. Form the quadratic. 5n squared plus 3n minus 4000 is greater than 0. Okay, now we've got to try and solve that. Will it factorise? Certainly looks unlikely. B squared minus 4ac, so 9 minus that, minus that. So it's going to be, doesn't look like a square number to me quickly. So let's use the equation. N is going to be equal to, so we're going to first find the roots. N is equal to minus b, so negative 3 plus or minus the square root of 3 squared minus 4 lots of a lots of c, all over 2 lots of a. So negative 3 plus or minus the square root of 9 plus 20, 80, 1000 all over 10. Tap it in the calculator. N comes out to be 27.99 or negative 28.59. Now we want to be greater than 40,000. So n's got to be larger. So n has got to be greater than 27.99. Therefore n equals 28. because we need integers. Yeah, n must be an integer. Yeah, n is a member of the set of integers because it's a term in the sequence. Since a position in the sequence. And we need to add up the first 28 terms here to get to an answer greater than 2000. Hope that's clear.